next speaker is Renee Shields, and she's going to tell you about the resources of the National Spatial Reference System here in Louisiana.
Good morning. Everybody hear me? Yes? Yes? No? Why? Another cup of coffee? My name's Renee Shields. I'm Height Modernization Manager at NGS. I want to thank Roy for putting this program together. I think what a great turnout. I think that one of the things that you all are going to find out after getting through these 2 days is that there's way more information that you need to know than what we can tell you here, because just about every presentation that's coming at you here in these 2 days is by itself you could spend a day talking about it, at least at a minimum. So hopefully you now know who folks are that you can come and talk to, and please come and ask me questions, introduce yourselves if I haven't met you already, and we're here to talk and let you know what's going on and hear what excuse me, hear what's going on from your side. Very good. I'm going to try and speed this up a little bit. Excuse me. I'm going to try and speed this up a little bit. I think Tim and Roy covered a lot of great material about what's going on here. I would imagine that there isn't too much that folks are talking about that you aren't already aware of, since you're out there having to deal with this every day. But I'm going to give you a little bit of an overview about NGS's role in all of this, what our mission is all about, what we've been doing here in Louisiana up to date to try and get a handle on what's going on here. My program specifically and what we're doing and where we go from there. Mission of NGS, very shortly, if you all don't know, is to define, maintain, and provide access to the National Spatial Reference System. We're looking at the reference system for the entire nation. And we're in Department of Commerce, so ours always revolves around commerce, transportation, and that's where our agency got started. So that's our driver. But basically defining a reference frame for everybody to use for surveying and mapping activities. Defining the NSRS, we sort of reiterated all of this in our 10-year plan a few years ago, redefined our mission, or clarified our mission, if you will. The NSRS, first and foremost, must be the most accurate that we can make it. Everything else that's building on that is relying on that to be the most accurate reference frame that we can give you. So that's what our goal is. Maintaining it is a little bit more difficult, and folks here in Louisiana know that as well as anybody. It was originally California that came to us to find out what we could do to help them with their vertical reference frame, but of course there are issues not just in California, but here, Alaska. There are subsidence things going on in Arizona and North Carolina, so it's having a dynamic region that you're dealing with to try and maintain that reference frame is a very challenging thing. So providing access to that traditionally has been through passive control, those disks that you see in all of these slides. If they're moving, and we don't know they're moving because we go out and we look at them and they look fine. Many of those you can pretty much tell something's going on. But if you can't tell, then how do you know you can rely on that information? So trying to find ways to make sure that information is as accurate as we can make it at the time that you need it, not just back when it was observed. So that's part of our challenge. One of the things that we're doing to try and provide that information to you is provide additional data on the coordinates that we give you so that you know when that information was measured, when that coordinate was derived, what the epoch is, and then of course now we've got active control as well in the course. So active control, you know you're getting 24/7, you're getting those updated coordinates for that. The NSRS, National Coordinate System, latitude, longitude, and height. Scale, gravity, and orientation. Gravity is a big part of this, and you're going to hear a lot more about that later on today. But not just that, but how these values change with time. How do we model that movement so that even when we're not out there observing, we can figure out where that position is for that mark? Of course, the components, the national, old slide, we don't have cooperative anymore, national cores, the network of passive monuments, part of the way most folks traditionally have accessed the reference frame. Official national shoreline is part of NGS's mission as well. And then the orbits for the global navigation satellite system that we use to define the NSRS. And of course, the models and the tools that go with that to describe how these quantities are changing over time. And you've seen a lot of these. The cranes going under the bridge up there, that's a fairly new picture I got from NOAA. One of my favorite examples of how difficult it is to try and get these measurements and figure out what these heights are and why it's so important, knowing the height of the bridge, knowing the depth of the channel, knowing the draft of the boat, knowing the height of the tallest mast or the crane on that boat. All of these things are critical, and if you don't know the relationship between the water levels, if you don't know where the ground is, where the bridge is, you can't provide that information to the pilots. Height Modernization is a program that's all about establishing accurate, reliable heights using global navigation satellite technology together, right now, together with leveling and gravity and other remote sensing observations. Over the course of the next couple of days, you're going to find out how important it is to have that, the leveling and the gravity information to eventually get to the point where we can use GPS by itself to get accurate heights. It's a big puzzle that we're trying to put together, and you're going to see how all those components fit together. Right now, we need the leveling, we need the gravity in order to be able to turn those heights into the orthometric heights. Very briefly, there are three kinds of heights involved. There's ellipsoid heights, there's orthometric heights, those are the ones we're after, NAVD 88, North American Vertical Datum of 1988, and an improved geoid model that provides the connection between the two. We want to find ways to get better ellipsoid heights. Dave Zukoski is going to talk about that a little bit later today. Better field procedures and the accurate ellipsoid heights to start with that we get from our cores. The improved geoid model, and we've got a program that we're working on for that. You're going to hear Jerry Mader talk about that a little bit. That involves collecting gravity data, and then in the case of finding the version of the geoid model you want to turn GPS heights into NAVD 88 heights, you need a specific geoid model to fit the NAVD 88. So benchmarks that have GPS on them gives us that important information. And then, of course, accurate orthometric heights on benchmarks to provide that control, that tie to the NAVD 88. So how do you do that in a region like Louisiana, southern Louisiana, where that ground is moving and those heights that were accurate 5 years ago are no longer accurate? Goals of height modernization. I'm going to blow through some of this stuff to get that on track. Accurate, reliable heights, 58, 59, Dave Zio talked about. Standards that are consistent, and data, technology, and tools that yield consistent results wherever you go. Now, that doesn't necessarily mean you're going to get centimeter level results in the mountains when you're using the same techniques that you use in the plains or on the shore to get centimeter level results, but you get the accuracy that you need to do the job wherever it is you need to do it. So that's what we're after. And the system or the process that's maintainable. And again, we're coming back to a dynamic region. How do you maintain the reference frame here so that you can use it? And Roy put up a whole bunch of diagrams that show subsidence. Again, once the ground has subsided, you've lost that tie to the NAVD 88. You no longer have that information. So you have to find a quicker, easier way to go out and reestablish that connection. Options for updating the control: we can re-observe and we can readjust. Traditionally, that's been done through leveling. Leveling is a very expensive and time-consuming process. The idea of going out and leveling to all the benchmarks across southern Louisiana time and time again every 5 years is not something that is really supportable, or really a good way to go. What we will do at NGS on occasion is special projects, and of course collecting additional gravity down here to help with the geoid model. Talk a little bit more about that in a minute. Model the motion, developing the tools that we need to perhaps apply to observations or apply to those heights so that you can determine and predict what the height's going to be at a certain point in time. So you can combine observations collected over a span of years, and you can reconcile those to a single epoch. That's another way that we're working on this. And of course, the metadata that goes with that, publishing the epoch, the information about where that height came from and when that height was established. Roy mentioned NOAA Technical Report 50. This was one of the early concerted things that we did. We've been doing observations here in Louisiana for a long time and watching what's going on here. In 2004, our then advisor in Mississippi, Kurt Schinkel, worked with Roy Daca, gathered all our historic leveling data, and basically developed this model, vertical time-dependent positioning model, VTDP. It's not really rigorous at this point in time. We're working to update that thoroughly, but it was a pretty good way of looking at what the subsidence was going on, what the rates were. We used first-order leveling that ranged from the early 1900s up to 1995. It went from Pensacola all the way over to the border of Texas. Included the relative sea level that we had at the tide gauges, and then of course cores. And of course the highest rates of subsidence we saw were in the Mississippi River Delta. This was the entire area from Florida all the way over. I think I've got that blown up. To show the network of stations that we observed in Texas and the rates. This report is available online if you want to get it and take a look at it, and it's actually got appendices with all the data, so you can look at specific stations that were used in this model. In 2004, we did a new leveling survey here, combined with GPS to get some additional information. We did an area south of I-10 all along southern Louisiana. We used VTDP to get those rates of change, get new heights on those stations, and then validated that with GPS. So where VTDP was working, we're able to use that as control in the survey. We got new heights out of it, and those new heights were actually put into the geoid model. We had geoid 03 out at the time, but we made a slightly refined version of that so that it would fit the control that we were now publishing in 2004. What we determined to do was publish just the heights on the benchmarks that were coming out of the 2004 adjustment. Any other benchmarks in the area were suppressed in our database. You could get that information, but you had to kind of jump through some extra hoops to do that. The idea being, we don't want you to go out there and use benchmark heights on stations that have not been observed for 40 years, together with the new benchmark heights that we're now using, that we're now publishing on the stations that were part of this project. To give you an idea what that means, this was what the benchmark network looked like, what is in the NGS database, and come on. These were the benchmarks that we observed. The circles are cores. The little triangles are the benchmarks we observed in this particular project in 2004. 99 benchmarks. Everything else around that area was suppressed. Again, you could go and you could get that information, but you had to be careful how you used it. So again, the before and the after. So you can see that there were a lot of benchmark control lost out of this. In 2006, with the help of FEMA, we were directed to do a post-Hurricane Katrina project to try and get some updated information on this. FEMA provided funding. We did a joint survey project with LSU with the help of Roy Daca. And our sister agency, Co-op, Center for Oceanographic Operational Products and Services, they manage the water level networks, National Water Level Observation Network. So we had updated tide gauge information from that. We included 27 parishes. We included the 99 benchmarks from 2004, but we moved the project area a little bit north of that so that we could kind of expand it, and we added some additional passive control to this particular network. We had additional cores. We set up a pilot project for GPS real-time in the area. You'll hear more about that tomorrow. We got additional new gravity observations, absolute and relative gravity, the terrestrial gravity, and the new tide gauges again. And as you can see, we kind of densified that area. The red again is what we had in the 2004 project. The smaller green circles now are the additional benchmarks that we were able to tie into and provide updated heights on. We use VTDP again to validate what control we had, if it fit the GPS, if it was consistent with what we were getting from the GPS observations, then we used that control, otherwise we readjusted it. The VTDP shift values that you can see, and you may not be able to see this real well in the light, I don't know, but I've got red circles are 2.5 to 3 centimeters in the period of time from 2004, 0.65, that's how we're expressing our epochs, from the 2004 projects to the 2006 project. 2.5 to 3 centimeters in those regions, 3 to 4.5, almost 5 centimeters in the regions with the blue circles. Again, not a real rigorous transformation or velocity model at this point in time, still being worked on, still need to get a lot of data to do this, but it really gives you an idea of how critical it's going to be to take all of this data and update the VTDP and make sure we have that model as rigorous as we can make it. So we're seeing some real significant stuff going on here. All those benchmarks that haven't been observed in 20, 30, 40, 50 years, you can imagine what the differences are at those stations now. In 2006 survey, after that we had 340 stations now, benchmarked passive control that we had heights on. We had observation data that will again go back into the VTDP and be used to modify that model, to update that model. Additional gravity and height information that was then put into the geoid model. Another thing that we were working at the same time was the adjustment, the NSRS 2007 adjustment. Out of that we got consistent, accurate ellipsoid heights, updated ellipsoid heights. And those ellipsoid heights together with the orthometric heights we were getting out of here went into the G 09 model to make that consistent. And then of course, again, suppression of other neighboring benchmark heights so that you're not able to use them consistently together. Let's see if I drew the line, yes. This is sort of how we determined what area we were going to suppress the heights. What we wanted to make sure was that there weren't adjacent benchmarks or a minimum number of adjacent benchmarks where you would have a published height from nearby from the new work and published heights that were still based on the old observations, stuff that wasn't observed in 2004 or 2006. So to do that, we kind of had to follow the level line, suppress everything south of that line. And we determined, we're basically calling that a sort of a suspected subsidence area. We know it's subsidence, but we don't have a real rigorous, at that far north, we don't have a real rigorous study to describe that. So that's the way we work that. The information is available. You still can get on and request suspect heights, but you have to be aware of when those heights were determined. The way we publish it, of course, this is a leveling, a benchmark further north. So this is outside the area. This is being published with the leveled observation, the leveled height up there, NAVD 88, that's adjusted. We've got an ellipsoid height on this, so this was included and this was observed by GPS. We've got a geoid height from the current model, G 09. When you try to match all of these heights together, you want to get as good a fit as you can get. The idea is that if the closer you know each of these heights, the more true each of these heights is, the better they'll all fit together. And unfortunately, I can't go into the relationships, but I think that's going to be covered a little bit later on. But if you try and look at the misfit between all of these, we've got a 5 millimeter, which is pretty good, from Geo-803. Actually have an 8 millimeter misfit from Geo-809. The target is to try and get these better. I looked at this and I thought, well, maybe I shouldn't put this one up there. It looks like we're not doing as good a job. I think the actual Geo-809 height is more reflective of what we know. The Geo-803 height maybe was better. That doesn't mean it was based on more accurate information. So one of the things we're trying to do, though, is to make sure that all of those heights that go into those models are as accurate as we can get them. So obviously, we still have a lot of work to do. Now, when you take a station that was observed in a height modernization project, again, Dave Z is going to go into the details of what that means. You have a note at the top that says it is a height modernization station. We do publish those heights to 2 decimal places. Not really the best way of expressing the accuracy. We're working on finding better ways to do that, but right now that's the way we do it. Leveled heights are published to 3 decimal places. Height modernization GPS heights are published to 2 decimal places. If you do a GPS project and it's not to height modernization specs, we will publish that height, but only to 1 decimal place. And then, of course, the ellipsoid height and the geoid height from that. All of the superseded survey control information that's there. Again, you have to be aware of the dates of when those heights come out. And then in areas where we've reobserved and we have a new height from the, in this case, the 2006 project, we have that information over here. So you've got an epoch associated with that. In this case, we get the message in addition to the epoch date. We get the message it's in the suspected area. And in this particular case, this station was one of the ones that was included in VTDP. So we took historic leveling data, and that was part of the original NGS NOAA Technical Report 50 that went into the VTDP model. And all kinds of other additional information down in the data sheet to make sure that you're not missing the point that this is in a subsidence area, and you need to be using this information with caution. And then this is how we're publishing those benchmarks that are not part of the observed network, but are near those benchmarks from the 2004 and 2006 projects. We basically put that it's not published. We take that height out of there, but we do still have this information here. Now we're revisiting some of these messages to try and make them more meaningful and less inconsistent. But we do still publish this information so you know that it was at one point in time leveled, and you can get some historic heights out of that. Right now we're still in the process of a 2010 survey in the same area. Now we have done all the observations. Originally we observed 120 marks. We had contractors working on that. We actually had some NGS folks go out and do some observations on an additional set of marks. Again, the observations are done, the GPS processing is complete, and we're undergoing the adjustment process right now. And again, we will be providing updated heights for the stations in this project, and then suspending publication of the heights for other stations that are not part of this project. These are the original 120 marks that we had the contractors working on. And our NGS folks observed some additional marks. Some of these may not be republished necessarily, but they will enable us to have some ties into some other networks. Mississippi DOT is doing a project trying to tie into some areas outside of the subsidence region so that we don't have a step at the border, say, where we've adjusted stuff in Louisiana, but you try and observe right across the border into Texas or Mississippi, and you've got a discontinuity there, so trying to make those ties. The Height Mod program, what we are doing with the program to move all of this kind of thing forward, and in general trying to provide updated heights across the country. Improving access to NEVD 88 today. That's where we started with height modernization back in '94. and trying, or not 94, 2004, 94, trying to provide NVD88 today, finding ways to take advantage of new technology to get accurate heights quicker. You're going to hear a lot more about that. Ensuring the control is current, again, like the 2010 project. Trying to find a better way for users to input data to NGS that we can use. Curiosity, folks out there in the crowd who may have submitted data to NGS from survey projects, anybody? A few brave souls. Generally the term blue booking strikes terror in the hearts of many, so we don't always get all the data that's out there. We're trying to find better ways to make that happen. Obviously, if we get data into our database, we can do a better job of modeling what's going on in dynamic areas, so we can really use that data. Data that we get from the outside, GPS on benchmarks, goes into the geoid model. Currently, that includes our gravitational model that we start with, but turning that into a hybrid geoid model. You'll hear a little bit about that later. So that information is important to us too. How do we make it easier to do? People can get data to us without going through the blue booking process. We've got maybe some answers to that, and you'll hear a little bit more about Opus later on this afternoon, I guess. Enhancing infrastructure where there are gaps, trying to find areas where maybe we need some additional information so that down the road, and we're going to talk about going to a new datum, down the road we actually have the right information to build transformations, to build these models. So identifying where there are gaps in the infrastructure to make that happen. Supporting the development of better geoid models, I'll touch base on that in a minute. Developing a plan for maintaining the datum. Again, we can do this until the cows come home. We can go out and reobserve over and over and over again. How do we find ways to monitor what's going on and to maintain that without just repeating ourselves constantly? So finding a maintenance plan for the datum, not just the reference frame, but for the datum. Encouraging partnerships and collaboration, again, relying on folks like Louisiana Spatial Reference Center at LSU and Roy Daca, some of our partners, and working with our users and our stakeholders to get information. And then supporting the NGS 10-year plan, which is available online if you want to see the details about it. We talk about improved products and services, attention to time changes, and one of the big things is our target in 2022. I know this 10-year plan went to 2018, and we had hopes that that would be our 10-year target. These things slip, so right now our adjusted target is 2022 to make this happen, to redefine both what we now consider the horizontal and the vertical datums, North American datum of 1983 and the North American vertical datum of 1988, replace them with new datums. And the whole plan is outlined in there why we need to do that. I think in an area like this, it's kind of obvious that there might be a better way to define the datum so that we can keep up with this dynamic area and provide that reference frame up to date with a new way to define the datum. Part of that definition of the datum is going to be that it's going to be based on a gravitational geoid model. We're going to kind of get away from doing the hybrid geoid model. So the new datum is going to be based on the reference frame that's defined by the continuously operating reference station network. We've got the cores and the gravitational geoid model. Okay, you get a lot of details on that later on this afternoon. And we do have new data managers that have been announced at NGS. I'm sure they are still formulating their plans. So over time, you'll be hearing more from Joe Evgen, who's going to be the new datum project manager for the geometric datum, which is replacing NAD83, and Mark Eckel, who's the project manager for replacing the North American vertical datum. Ronnie. Oh, I put them backwards. Okay. What I said was correct. What's on there is wrong. Thank you, Ronnie. The transition to the future. GRAV-D, Gravity for the Redefinition of the American Vertical Datum. I'm not sure if Jerry goes into a lot of details about GRAV-D, but basically it's a survey project that we have planned to do aerogravity, to collect aerogravity data over all of the United States, the conterminous U.S., Alaska, our possessions in the Caribbean, Hawaii, possessions in the Pacific. We're basically going to use that gravity data to provide a geoid model that's consistent, a single geoid model consistent from equator to pole and this whole quadrant from the Caribbean over into the Pacific. We are collecting aerogravity data. It's quite an involved project at this point in time. We're having to develop new software for processing the gravity data, software for processing the GPS on the plane that's collecting the gravity data, analyzing the absolute gravity data that we have. This is going to be put together in conjunction with satellite gravity data that we have, the absolute and the relative terrestrial gravity data, and producing a highly accurate geoid model based on that gravity. The target is a 1 centimeter geoid. If we can have a 1 centimeter accurate geoid model, then we can maybe have our GPS down to 1 centimeter, and with GPS you can get 2 centimeter heights. So that's the target. And this will be how the vertical reference frame will be, the vertical datum will be defined with this particular geoid model. And we have a maintenance plan for monitoring what's going on with the geoid, for monitoring the gravity field and redefining the geoid model as we need to. Height modernization focus revolves around the NGS business plan, if you will. Infrastructure, again, the cores is as good as it can be, defining a foundation cores that we're going to define the reference frame on, making sure that the passive control network is up to date. When we go to these new datums, we'll be providing a transformation tool for you to transform from NAD83 to the new datum and NAVD88 to the new datum. If the infrastructure is not in place to provide the data to do that, it's not going to be a very good transformation, so we want to make sure we have that in place. Inclusion of data in the database to improve the models, providing metadata on the data sheets, and I talked a little bit about that. The multi-year course solution, I can't get into that. We've had a number of webinars. I hope you've been able to tune into some of those. If not, you can get some information off of our webpage on that. Basically a new adjustment of all of the cores to make everything consistent, and then a project to adjust all the GPS observed passive control in our database to be consistent with the cores. So we'll finally have one consistent reference frame between the two. If you want more detailed information on that, you can see me later. Guidelines, models, and tools, and of course you're going to hear about real-time guidelines. You're going to hear about NGS 58 and 59, how to get good heights out of GPS. The modeling, improving the VTDP, perhaps having a single velocity model. We have horizontal time-dependent positioning that works very well out in California and Alaska and elsewhere, so having a single model for that. Developing all the tools. The Opus Variety Pack, I call it. We have a lot of varieties of Opus, and Mark Chenoweth is going to talk a little bit about that later. He doesn't have a lot of time, so I don't know how much he can give you, but good things coming our way that way. Our outreach and capacity building, of course, our advisor program. We have advisors here you're welcome to come and talk to. We have conferences and workshops that we give. We have a training center now in Corbin, Virginia, and if you can't come to the training center, we present a lot of webinars through that. You can access the calendar for the training center online, and I think we've worked with most, Louisiana being one of them, most of the surveying societies so that you can get continuing credits if you need them for those. Federal Geospatial Summit. We are working with our federal partners to try and prepare them for this transition to the new datums. And the first stage of that was a major summit we had with all of our federal mapping partners last April. And we have another one coming up in a year. We'll be having out in California. And regional partner meetings. My program is trying to work very closely with partners in a region to find ways to address common objectives and goals, find ways to collaborate together and make some things happen, both educationally and with infrastructure. And an idea of who some of our partners are. Academic institutions and state and local governments are partnered with us. We've been successful up to recently in obtaining funds for grants for some of these partners, but of course we know the federal government funding right now is questionable, so we don't have any sign of having some funds to share in the near future. Hopefully that will change. But with those funds, some of our partners at the state and local level or at the universities have built what we call spatial reference centers, sort of a mini NGS to help serve the local user community. Louisiana State University is one of those, with Roy Daca managing this Louisiana Spatial Reference Center. Other offices in NOAA that we work closely with, and of course our other federal partners, including FEMA, including the Corps of Engineers and USGS. One of the projects we're working on with USGS is to try and make sure their stream gauges are updated, and we're making a little bit of headway with that of late. Make sure they're all on the same datum so that our own weather service that uses that information can build better hydrologic models and inundation models from that data. And sort of a last slide here. This is one of the plots I have from 2006. And this one particular station, I just went and found all the historic heights that came from this one station, what we have published on our data sheet. In 1965, this had a field height, leveling field height that was 1.1 meters. In 1986 survey, it was 0.93 meters. The NAVD 88 adjustment probably took all that information or some of that information and adjusted it, came out with a sort of an average. I think that's what happened there. And then of course in 2004 in the GPS project it was 0.67 meters, and in 2006 it was 0.65. So obviously a lot of subsidence going on in that area. Just one station. And we're pretty close to being back on track. So that was the quick and dirty version. And maybe we do have time for questions. I don't know. Roy's not here. So any quick questions? Okay. Then I'm going to give you Cliff Munier. Thank you.